What happens when we multiply an irrational number by another irrational number? Let's find out. Say we want to multiply square root 2 and square root 3. So how do we multiply this? We know that if we were to multiply the number 2 and number 3, this will be simply 6. If we have, for example, 2.1 times maybe 3.8, I'm just randomly writing some numbers, we know how to multiply, right? So we can actually say this is 21 by 10 and this is 38 by 10, right? And then we simply multiply 21 and 38 and we have here 100 and then we put 2 decimal places, right? So here, the way conceptually what we need to do is we need to just multiply these two. But square root 2 is really 1.414 and this goes on. This is a non-terminating, non-repeating number. Similarly, square root 3 is 732 and this is a non-terminating, non-repeating. So what we are to do is we have to multiply these two numbers. So now there will be decimal here and there will be some number over here. And now this part, the decimal part, now this is a non-terminating, non-repeating in both cases. So when we multiply, so first thing is that we will have a non-terminating number. Also this will not repeat because there are no set patterns here and here, right? So there won't be any patterns here. That means our final answer, this will be a final answer. It will be such a number which will be non-terminating and non-repeating. So this will be an irrational number. So when we multiply this, we are going to get an irrational number. Now, if you are given this question 10 times, 9 out of 10 times, you are not going to do it like this. Why? Because it does not really make sense. I mean, what is the point in doing a multiplication where we really cannot actually show an answer? But conceptually, it is important to understand that why when you multiply these two irrational numbers, we get an irrational number. So 9 out of 10 times, how are you going to write this? The way you're going to do this is, you will say the answer is square root 6. Now, this is important because what we did here is that we have square root 2 and we have square root 3. So the way we solve is we do a square root like this, and inside the square root we write 2 times 3, right? And then this will be simply square root of 6. Let's take a look at some more similar things. So let's say we have square root of 3 times square root 10. So what will this be? This will be simply square root of 3 times 10 or square root 30, right? What about if we have, say, square root 2 and maybe square root, let's say maybe something like maybe 30. What happens here? So clearly this will be square root of 2 times 30, right? Or we can say this is square root of 60. Now, if we were given this question and if we leave the answer like this answer is correct, but we can actually simplify this even more. What do we mean by that? So remember that when we have 1, and if we say 1 square is simply 1 times 1, which is 1, right? If we do a square root of 1, then we get 1. So let's understand this one more time. So if we have the number 2 and we square it, we get 4, right? Which is 2 times 2. So if we square root 4, we get the number 2, right? So similarly, if we have 5 square is 25. If we square root 25, we get 5. But one way to think about these, right? It can be, so let's say 25. So if we were given 25, how do we get to 5? So one way to think about that is, in the square root, so 25, you can write that as 5 times 5, right? Now you have 2 5s, right? So one of the 5s will come out and then you will be left with what? Will it be 0? No, because we can write 5 times 5 times 1, right? 25 we can write 5 times 5 times 5. So one of the 5s comes out, right? One of the 5s, it comes out and we are left with 1, right? Or we know that square root 1 is 1. So this will be 5 times 1, or just 5. So for every two same factor, one factor comes outside the square root. So here we have square root 60. So we are going to break down 60 into all prime factors. So what can we say about that? Well, we can write 60 as 2 times 30, right? We know 2 times 30. 30 we can write as 3 times 10, and 10 we can write as 2 times 5. So if we multiply this, this is 10 times 3, 30 times 2, 60. So 60, we have written it into all prime factors. And now what we are saying is for every two same factors, one of them will come out. So we have 2 and 2. So one of them will come out. So we will be left with here. So when 2 comes up, we'll be having 1 times this 3 is still inside square root, and the 5 is still inside square root. In other words, now we have 2 times 3 5s are 15 times 1 is 15. So our answer is 2 square root 15. So when we multiply square root 2 and square root 30, we get square root 60, and this is a perfectly valid answer. But we can simplify this further, and we can simplify this the way we did it, and we will get 2 square root 15. So now let's take a look at, I think we diverted a little bit from our main goal, which was to find out irrational number times irrational number. So let's take a look at some more examples. See, let's say we have a number 2 square root 2 multiplied by square root 3. So we know that a rational number times irrational number is an irrational number. So this is definitely an irrational number, and this is also an irrational number. So how do we do this? Well, we will say this is simply 2. 2 square root 2 simply means 2 times square root 2. And this we have square root 3. And the way we are going to do that is this will be 2 times square root of 2 times 3, or 2 times square root of 6, or we write it simply as 2 square root 6. So this multiplication will be like this. And this is an irrational number. Why? Because we know, when we have seen earlier, when we multiply a rational number to an irrational number, we get an irrational number. Now let's say we want to have, let's write one more example. Let's say we have 3 square root 5. Let's multiply this with minus 2 square root 2. So how do we do this? Well, this is a positive number, this is a negative number. So our final answer is negative. Or we can write this as maybe simply 3 times square root 5 times, we can write this as minus 2 times square root 2, right? And then we can multiply the 3 and the minus 2, and then we will multiply 5, square root 5 and square root 2. So this will be minus 6 multiplied by, we will have square root of 5 times 2, or this will be minus 6 multiplied by square root of 10, or simply minus 6 square root 10. So let's take a look at one final example. Let's say here we take something this time, maybe square root of say 7, and let's multiply this by maybe say 3 square root 6. So this one will be simply, here we have 1, so this will be 3 times square root 6 times square root 7, or this will be simply 3 square root 42. And can we simplify 42? There are no common factors here, right? There are no common factors here. So if we were given, say, square root, let's take a look at one more example, square root 2 times square root 4. This will be square root 8, or 2 square root 2. Because 8 is 4 in 2, and we can write the 4 as 2. So square root 4 is 2. So 2 times square root 2. So this is the answer. So what is important here to understand is that all of these are irrational number multiplied by irrational number. Irrational number multiplied by irrational number. Irrational number multiplied by irrational number. In each of these examples, our answer is an irrational number. Irrational number, irrational number, irrational number, irrational number. Right? So can we say that when we multiply two two irrational numbers, we always get an irrational number? Well, why don't we take a look at one final set of examples and then we can draw a conclusion. So let's say we want to multiply square root 2 by maybe 2 square root 2. So how do we do this? Well, this will be simply, this is 1, right? So we will write 1 times square root 2 times 2 times square root 2. Or we have 1 times 2, this and this, multiply by square root of 2 times 2. Or here, this will be 2 times, now there are two same factors, so one of them will come out of the square root. So 2 square root 1. Or this will be 2, this will be 2, and square root 1 is 1, or 4. Now, this is an irrational number, this is an irrational number. Is this an irrational number? Actually, no, 4 is very much a rational number. Isn't that interesting? Let's take a look at one more example. Let's say this time we take square root 3 and we multiply this by, let's say we multiply this by maybe 5 square root 27. So what do we get now? So let's do it. So we have here, or maybe let's make it interesting. Let's say this is square root 3 by 2 times 5 square root 27. So we can write this as 1 by 2 times square root 3 times 5 times square root 27, right? Or we have 1 by 2 times 5 times, we have a square root of 3 times 27. Or this one will be simply 5 over 2, right? And here we have, what do we have here? So we have to expand the number into all prime factors. So 3 is 3 and 27 is 3 times 9, right? And 9 again we can write 3 times 3. So what we have, let's do it over here. So what we have is 5 over 2 times, now for 2 of the 3, 1 3 will come out. So we have 3. And then here we have again 2 more 3. So another 3 will come out. So we will get 1 more 3 and then we are left with square root 1. Or this will be 5 times 3 times 3 and square root 1 is 1 by 2. Or simply 3 5s are 15, 3s are 45. 45 by 2. So this is very much an irrational number. This is an irrational number. When we multiply, we are getting a rational number. So what we really see is that when we multiply two irrational numbers or any number of irrational numbers, we may get a rational number and sometimes we may get an irrational number. This is very much different from when we were adding irrational numbers or when we were subtracting irrational numbers, because there we were getting almost always irrational number, with the exception that if you obviously subtract same irrational number from itself, you get 0. But otherwise you will always get, during addition and subtraction, you will always get irrational number if you are working with irrational numbers. But when it comes to multiplication, sometimes we will get rational numbers and sometimes we will get irrational numbers. And this is true for both multiplication and division.